Okay, we want to find the following limit. 1 over h, the integral between 2 and 2 plus h of the square root of 1 plus t cubed dt. Okay, so this is a limit, but it looks like a ratio. Okay, but before this, so this is an integral, and we want to find the limit. That means like derivatives. It looks like a derivative. We have to write it like a derivative. To be able to solve this one, we need to use the fundamental theorem of calculus. So what's the fundamental theorem of calculus? So given a function that's continuous and defined on some interval ab, okay? So this is our gt. The integral of between a and x of gt dt that we define by a new function f of x. So the derivative in this case, f prime of x, is just g of x. So that's what we're going to use here. So we're going to use this function here, the fundamental theorem of calculus, to find this limit. To do so, we need to make it look like this. Okay? So clearly our g of t is given to us. So f of x, a is 2, and let's put x here for now, and g of t is just 1 plus t cubed dt. So this is f of x. And what's the derivative according to the fundamental theorem of calculus? F prime of x is just square root of 1 plus x cubed. So this is the function. Okay, but here we want to use the definition. F prime of x is the limit, but we want to compute some value. Here, clearly, we need to make it appear like this one. Okay, so we want to make it appear between 2 and 2 plus h. So what's the definition of the limit, the derivative? So it's the limit as h goes to 0 of f of x plus h minus f of x over h. Now we have our h. Okay, so it's the limit as h goes to 0. We're going to keep the 1 over h outside, and we're going to use our f. Our f is given here. So it's going to be f of x plus h. That means it's between 2 and x plus h. In this case, x plus h. Okay? Square root of 1 plus t cubed dt minus f of x, which is the integral between 0 and x of 1 plus t cubed dt. Okay? Sorry, here, 2, between 2. Sorry, here. It's because f of x is between 2 and x. So that's the problem. Okay? And here, I can make one more change to get rid of this part. I can integrate between 2 and x, and after that, I go from x to x plus h. Let's write it down. So the limit as h goes to 0, 1 over h. So I can go from here 2 to x, 1 plus t cubed dt plus x plus h, square root of 1 plus t cubed dt minus 2, and the integral between 2 and x of the square root of 1 plus t cubed dt. I could have done something. I could have switched this integral, use the minus sign as a plus, but anyways, both of them are lead to the same thing. Now we get rid of this. I can get rid of this. So what's left? So here I have the limit as h goes to 0, 1 over h of x plus h, 1 plus c cubed dt. Okay, now what's my integral is asking? Compare these two. My integral is asking me to evaluate for x is 2, this derivative. So here is just, this is just f prime of 2. And I know f prime is just the square root of 1 plus 2 to the power 3, which is 9. That means 3. So the value here, this limit here is just 3. So my answer to this question is that the limit here, what's this limit? Let's call it that it's 3. Okay. So I don't want to jump and write down the limit, but we have to use all these steps. We could have used something here instead of this minus. We could have switched this one to minus, and we flip these bounds, so it's gonna go from x to 2, and we can get rid of these 2 here. Okay, so we're gonna have an integral that goes from x to x plus h, but both of them work. Okay, and here when I come down here, I see what's the value that they're asking me for. Here it's 2, so my x is 2, and I plugged it for the derivative, because I know the derivative by the fundamental theorem of calculus. Okay, anyways, this shows that the limit that we are looking for is equal to 3. Thank you.